My name is Billy Korando. I'm a developer advocate with IBM. You can find me at Billy Korando on Twitter, and you can also email me, william.korando@ibm.com. If you have any questions about OpenJ9 or things about IBM Cloud, definitely don't hesitate to reach out to me. I'm more than happy to answer any questions you have, and if I can't answer it yourself, I probably know the person who can actually answer it for you. So don't hesitate at all to reach out. So this presentation, we're going to be talking about Eclipse OpenJ9, a lean, mean Java virtual machine, particularly for the cloud. If you leave this presentation with an intense desire to know more, I have blogged a bit about OpenJ9. You can find that at that link on my blog site. And then also, we'll be showing a code demo here a little bit later in this presentation, and you can find that at that link to my GitHub. So you can also check that out, and I think I also have some links on the main page there to also some blog articles and other information about OpenJ9. Also, part of the team I'm at with IBM, the Global Java Developer Advocacy team, we have a Java newsletter. We send it out monthly, and it's just a kind of what's going on in the world of Java, upcoming conferences, and maybe some new developments like what's coming out in Java 14, for example. And also we have some great documentation whether you're doing Spring or I guess much more people here, Jakarta EE. We have some great documentation at cloudibm.com/Java. That said, let's really get into the presentation because we are on a limited amount of time. So why would you even care? Why would you care about having a leaner Java virtual machine runtime? So ideally, demand would look like this. Constant and consistent, you could just buy the capacity and exactly meet it, and then it's just kind of, you're just done with it and you can go along with your merry life. Of course, that is not what demand is like. Demand is always going to be constantly changing. So organizations have been always working on how are we going to address this demand. So back in the old days, 10, 15 plus years ago, well, most organizations just did this through bare metal. They would go out, purchase some really big, large machines, get them all hooked up and have their own ops people running and maintaining them down in the basement or maybe under a stairwell or something. And so this was what it would look like then. You would have this big block of capacity and you would have your demand, but the problem with this is anything that, any capacity that's above that demand, well, that's just wasted capacity. This doesn't matter too much when you're just kind of running this bare metal. You maybe have some capital loss expenditures just because maybe you never actually even close to your capacity that you can do with your server, so you maybe just kind of overspent, but otherwise you're maybe just wasting a little bit of electricity. But as organizations went on and time and technology improved, we found better ways of handling capacity and demand, and just being a bit more flexible. And the kind of way we did this was with virtual machines. And so with virtual machines, we are a bit more granular. Instead of just having one single big block of capacity, we could be a bit more flexible. Maybe capacity would really dip, maybe perhaps during a certain time of year, so we can maybe spin down a virtual machine, apply it to something else for testing or development purposes. Generally, at least, most organizations I've been with that did virtual machines, spinning up and spinning out a virtual machine was a pretty timely task. So this demand capacity would again probably be on a weekly or monthly or annual basis in order to actually even spin up and spin down. But again, time goes on, time improves, and we're kind of entering modern day where we have containers managed on public cloud platforms. And so what you get with these is the ability to rapidly spin up and spin down in response to demand. Whereas before, I was mentioning you'd either have to kind of purchase bare metal machines, which require a lot of upfront planning. Now you can quickly respond to current demand to increase capacity or reduce capacity. But still, we have a little bit of waste in there when we're doing this. So what's the benefits of running the cloud? Well, of course, probably I've heard this many times, and I was just saying, incredible elasticity. You can respond to demand just like this, and you can also spin down as well. And there's also no upfront capital cost, so you're not going to really have to have that annual meeting where you have to plan out okay, we're going to allocate millions of dollars to buying some new capacity to maybe meet expected demand. So the cloud gives us this incredible compute capacity. We turn this faucet, and out comes this computing capacity to meet whatever demands of our business. Now, I probably spent about 40 or so hours putting together this presentation, and about 39 of it was putting together that animation. So I really hope you appreciated that really high-level animation to demonstrate using cloud computing. But of course, organizations, cloud platforms, we are not providing these platforms out of the goodness of our heart. Just like your water faucet, the demand is metered. So you have this computing capacity, and you have to pay for it. With Java, there's a very direct relationship between the cost of, or the max memory you set for it, and then how much it's going to be costing to run that application on your cloud platform. So if you're going to be setting it to 512 megabytes or a gigabyte or so on, that's going to have a pretty direct relationship with the cost of running that application on production, or just the overall cost, how much you're going to capacity you're going to need to be able to run all your different applications for your organizations. Additionally, so traditionally profiles would look something like this, because many of the applications we have written, they would start up at one point and then maybe run for really for days, months, maybe even longer. So it really didn't matter too much if it took a couple of minutes, even longer, to actually start up and reach full capacity, because it didn't really matter within the context of an application that's going to be running for possibly hours, days, or longer. So we would have a slow ramp up in time. And then also, there would be with like applications with the JVM doing JIT and optimizations, there would be a bit of a resource hump where you go a little bit higher, but then kind of maybe flatten out going over time. And so this is lag in before you're having all this capacity you need, but it's going to be a while before you actually be able to take full advantage of the capacity. And then also you maybe have to put like a little extra capacity in there to kind of account for this peak in resource usage. So again, this kind of leads to waste. Now granted, that's only a small amount of waste compared to the much larger part where you're actually really making good use out of that capacity. But again, to go back to the faucet analogy, well, a leaky faucet can be pretty costly over time. So what that little bit of waste looks like is perhaps this when you apply it across all of these different containers on your cloud platform. And that can start to add up to where you're spending a lot of money for this capacity, but you really aren't making the best use of it. So what are the demands of running in the cloud? Well, we need fast startup. So if we're going to be able to rapidly scale up and scale down in response to demand, we need to have that new capacity, those new instances become available and be fully usable as quick as possible. We also want minimal memory footprint. So for each new instance we're spinning up, we don't want to have to allocate huge amounts of memory to start running it, because that's, again, going to have a very direct impact on how much it costs to run our applications on cloud platforms. Minimal CPU usage, again, pretty much the same thing, that both memory and also CPU is going to be related to how much it costs to run these applications on cloud platforms, so we want to minimize the CPU usage. Small deployment size can also be helpful for elasticity and also just getting the things deployed out there. And also no resources uses when idle. So you can always have a certain number of instances always running, always available to respond to demand quickly. But if they're not being actively used, you may want to free up those resources to be used by other applications that might be actually used at that time. Also, ideally, the profile would look something like this: a very rapid startup to reach full resource and throughput usage, and then leveling off again, not really having that peak in resource usage. So this is where, of course, Eclipse OpenJ9 comes in. OpenJ9, Eclipse OpenJ9 was open source back in September of 2017, so just over 2 years ago now. And it's dual licensed under the Eclipse Public License 2.0 and the Apache License 2.0. So what this means, though, is it's completely and totally free to run OpenJ9 on your cloud platforms, and you never actually have to pay IBM anything. So IBM is one of the main backers of OpenJ9. That said, there is runtime support offered by IBM for OpenJ9 or any Adopt OpenJDK runtime, so that's available if needed, because that is, of course, important for some organizations. But a little history on OpenJ9. So first and foremost, and we hear this all the time, OpenJ9 has no relation to Java 9 other than, of course, it could run it because it is a Java runtime or JVM. But where that name comes from is originally, back in the early 2000s, J9 was built off of a Smalltalk VM called K8. The developers of this VM, well, they thought at the time Java was a step back from Smalltalk, but they thought the new VM was going to be a step forward, so that's where J9 comes from. And I guess maybe it's just a happy coincidence that also J and Java line up like that. But that's the history. I've checked with our J9 developers, and they kind of confirmed this, so I'm going to go with it. And that's where I also got that information from. But originally, the background for J9 was to be running on mobile and embedded devices. So it actually did run on the Nokia 9300, 9500, and as I mentioned, embedded devices. But what are the demands of running on these kinds of devices? Well, back in those days, mobile devices and even now embedded devices are going to be seriously resource constrained. So you need a fast startup, so you're not going to have much battery, and users are going to have the responsiveness as well, so you need to start up immediately. You also need memory, or minimal memory footprint, because again, we're going to be talking about only having a few megabytes of memory available, so you can't just take up gobs of memory. And same thing with CPU. We're talking small CPUs, mobile CPUs, ARM machines. They're not going to have a lot of horsepower behind them, so you have to make the best use of them possible. Small storage footprint, again, not much storage space available, and no resource usage when idle. That kind of goes back to like maybe power requirements. But all this sounds very familiar to what we were just talking about for running on the cloud. All right, so maybe enough talk about OpenJ9. Let's actually see it in action. So the demo of what I have is I just went out and got a bunch of Docker images, just a baseline, no JVM tuning or anything. And I got Hotspot, Korando, and Graal VM, and then also OpenJ9. These are all running Java 8, and it's images from back in about like November of last year when I kind of put this demo together. And so what I did is I built a simple Spring Batch application, and it's just kind of reading a bunch of data from a CSV file, and it's just performing a bunch of different tasks on them. You can kind of see here, mostly you just wanted to make sure it's not like doing something overly simple like, oh yeah, look what happens when OpenJ9 does like a bubble sort or a binary tree search or something like that. That's maybe not necessarily realistic of what workloads look like for most organizations. So I wanted to do something that somewhat simulates that, but also maybe avoid hardware-related issues. So I'll try to keep everything in memory. That said, let's see what happens and how we can compare OpenJ9 to these other popular JVMs. So I know this text might be a little small. As I mentioned, we have 4 JVMs running in Docker containers here. Korando, Hotspot, Graal VM. So Korando is the green line, Graal yellow, Hotspot is blue, and then OpenJ9 is the orange line. But as you can see up there, Hotspot, or OpenJ9, is running about half the memory usage of all these other JVMs. And we can also see, I don't quite like how CPU usage is visualized, but also you're getting much less memory usage, but you're not also paying for that in CPU usage. Actually, CPU usage is even less with OpenJ9 when compared to Korando and Hotspot, which of course makes sense. Korando and Hotspot, or Korando is built based off Hotspot, so it's going to be pretty similar performance. Of course, some of the times the problems with running these live demos is, for some reason, I've been noticing a couple of spikes today when running this. Not quite sure where those are coming from, but sometimes that can just happen just because we also have like 4 VMs all running at the same time, so there could just be sometimes like thread locking issues. So this application, or this running through this, will probably complete here in about 10, 15 more seconds. So it's great that we're using about half the memory of these other VMs and also a little bit less CPU, but we also need to make sure that we can't just say like, okay, we're using half the resources, but then it's going to take twice as long to run. So it looks like Korando just finished up, and then Hotspot shortly after, and hopefully here in just a couple, yep, so OpenJ9 also finished, and we can actually see the real times here. So Korando finished in 104 seconds, Hotspot 108, and then OpenJ9 115. So there's a small throughput loss, but it's not much. So you're getting a huge memory savings, and you're not really having to lose much throughput with it. So you're going to still have pretty similar performance compared to what your typical hotspot looks like. But that's all great. But, and then, sorry, I guess one of the important things is just, it's running the exact same jar in all these Docker containers. So to get these benefits, it's not like you're going to have to go and like rewrite your applications or recompile and rebuild them. You can take your exact existing jars and then just drop it on your OpenJ9 runtime, and it should just run perfectly fine. And then to have some actual like testimonials about this, one of my favorite is Charles Nutter here up in the, I guess that'd be the top right-hand corner. He is like the lead architect on JRuby, and anyways, you can kind of see in his tweet there that he ran like all his tests against JDK8, OpenJ9, and 99.996% of them all pass. And I like that one just because JRuby, as like a actual programming language, is going to be kind of running a lot more edge cases. So it's a pretty realistic load and kind of edge cases around to see what it would actually run like. But we also have some other examples of people also running actual workloads in production using OpenJ9 and having success. And that's also generally what we hear back from the community as well, that like, hey, you know, it just kind of runs and, you know, we're just using less memory now. Of course, you can tune OpenJ9, so there's going to be different needs for organizations. But also one of the nice things is that, okay, you have like all your ops people, and they're all used to Hotspot and how to properly tune it. And OpenJ9 supports a lot of these same JVM arguments that Hotspot supports, and it also means the same thing. So of course, like max memory usage, initial memory usage, and a bunch of other ones. They all mean the same thing in OpenJ9 and support it, so that's going to make it a little bit easier in that migrating process. But it's important to understand that when it comes to tuning, performance isn't just purely about throughput. Of course, that may be very important for some organizations, but there's other considerations like resource usage, you know, as we're kind of touching on. You may also have things like startup and ramp up. So Matt was just talking about serverless just before this presentation. Of course, in serverless, having a very, very rapid startup is really important because you're going to only have like a very short lifetime, potentially for some of those serverless functions. And of course, footprint, and this could be other resource and tuning considerations as well. So some different ways you can tune it. So one is tune virtualized, and this is kind of tuning for containerized environments like running on Kubernetes, has like better like idle management, a little bit faster startup and ramp up times, though there is a small drop off in throughput. If you are going to be doing serverless with OpenJ9, I recommend using Quick Start. Again, there's a pretty substantial trade-off between startup and throughput, so if you're going to have a long-running process, you wouldn't want to use this, but it is great for short-lived functions. There's a lot of other tuning options. Container support, which is enabled by default, but you can also tell it exactly how much of the memory within your container to use. Another couple is like idle tuning compact on idle, and then idle tuning garbage collect on idle. It's kind of like, you can almost think about defragging a computer. Like it's kind of, when it goes idle, you can put it into like better memory paging and then clear out those memory pages to free up more memory for it to be used by other processes. One other thing, one of my favorite features though, is like, so JVMs do a lot of repetitive work. So we're kind of talking about, again, with platforms, spinning up and spinning out a bunch of different instances of JVMs. And every time it starts up, it's probably going to go through a lot of that same processes of building all the class files and doing those optimizations. Just doing that over and over again. And this cloud, we're not going to tolerate redundancy in it because we're actually having to pay for that. We're having to pay for those CPU cycles, that memory usage, and so on. So we don't want to have to be paying money to do the same work over and over again. That doesn't really have a whole lot of business value. So what is great with OpenJ9, JVMs can really work together. So we can do class sharing. And so, yeah, we have a class file, and this isn't the best way to really store class information because you're storing both stateful and stateless information there. So OpenJ9 can split that into two parts. So you have a read-only part that's completely space independent. So like that's going to be storing like the name of a class, method names, member names, and so on. That stuff is going to change between class instances. And then, of course, the stateful part where that's actually going to be storing the actual member and values of those variables. So what this would actually look like in practice is like you have a bunch of different JVMs here. And yeah, you have the stateful part at the top, but the stateless part below, all those are identical between them. So instead of, again, having every JVM build those stateless class files, you can just share them. So to share class content, you simply need to do X share classes to enable class sharing. And you can also determine the size of the class sharing cache as well. So maybe you only want to share a small amount of it, or you can share a large amount of it. And you can also kind of determine, also how aggressive you want to be with the optimizations as well. But kind of what we have seen and heard back is it about reduces startup time and footprint by about roughly 20% or so. And actually, I don't know, did anybody see Steve's pool presentation? I know he kind of actually touches on this. So we're actually putting together Docker containers now that actually have a bunch of class sharing content already within them. So the majority of the actual like Java code that you're actually be running on your applications is actually already like handled within like your application server. So we're going to actually be putting together containers and sharing them that already have like all the class sharing content for things like OpenLiberty and WebSphere in them. So you really probably actually, a little bit of this stuff is actually a little bit no longer needed, but there's a couple of ways you can do it within Docker containers. One is a Docker volume, or as kind of mentioned, is maybe with a pre-warm Docker container. Yeah, this is probably no longer a recommended way to kind of update this part of the presentation. That said, let's take a quick look at some different ways of tuning some JVMs. So with the previous demo, I was comparing OpenJ9 to the other JVMs. In this one, I'm just comparing a bunch of different OpenJ9 JVMs and just have them compared to one another. So here we can kind of zoom in. So the one in the yellow line is like resource tuned, so I'm just trying to minimize the resource usage as much as possible. One is just kind of what the baseline, again, with like no JVM args set to it. Another one's just maybe like some standard tuning, like turning on class sharing. And then another one is tuned to have as quick a startup as possible. So you can just kind of see the different options. For some reason, the tune one's been spiking on me again a little bit. But we can kind of see here a little bit just the different performance profiles. I'm by no means a ops or JVM and performance expert. I kind of came into this just being just like a normal Java dev. But when some of my colleagues, when I first joined IBM, so me OpenJ9, just got really interested just because from that first demo I showed you, it's pretty cool to see how OpenJ9 just had this huge memory savings compared to other JVMs, and then not actually having to do a whole lot to take advantage of those usage or that huge performance boost. But here I'm just kind of showing then just like the difference in performance and like also like the different throughput for it. And yeah, so the baseline things up the fastest time, tune just a little bit after it, and the resource one is a little bit slower. And then kind of as I mentioned, the startup one, it's taking the longest to finish up just because the quick start, when you enable that, there's a pretty significant trade-off in it between startup time and then the overall throughput. So again, you really only want to use quick start on very short-lived applications. One thing, speaking of JITs, one thing that's still in development is what's called JIT as a service. So of course, every JVM has its own JIT that it has carrying around, and that's what does like the class compilation and optimization. But instead of having every JVM hold that, you can have like a headless JVM running that acts as a JIT for all these other JVMs. And so it makes those each individual JVM much smaller. And it's just a lot less CPU usage, and there's also no memory spikes and from JIT optimizations. So probably a little bit what's happening here with some of these spikes is some optimizations and so on are happening, which is kind of leading to that spiking occasionally. So you shouldn't see that as much. And so it can also maybe let you do a lot more optimization exactly around what your application needs. So allows your ops people to do a lot more fine-grained optimizations within their tuning. This is still in development, but you can, here's just a little highlight of how you can enable the JIT as a service. But like I said, it's still in development, but I think we're getting really close to actually having it to be real fully publicly available. You can read more about it here, and I forgot to mention earlier. So you can go and find OpenJ9. It's available at adoptopenjdk.net. So we support all the current supported runtime environments, so Java 8, Java 11, and Java 13. And yeah, if you go to adoptopenjdk.net, you can just simply select OpenJ9 as your JVM implementation instead of the standard hotspot. And yeah, here's some additional documentation to read on how to use OpenJ9. And yes, as mentioned, adoptopenjdk.net. If you want a link to the slides, you can get them here. For the code, as I mentioned, there as well. And if you're also interested in signing up for an IBM Cloud, there's a link as well. Does anybody have any questions then about OpenJ9 and how to use it, or